All right, hi everyone. Hi. I'm sure you are having a great time here at MarkLogic World San Francisco. And welcome to the session, Putting Spark to Work with MarkLogic. My name is Hemant Puranik. I am part of the product management team here at MarkLogic. And I joined MarkLogic about a year ago. Before that, I used to work at SAP in their information product management division. So I worked on technologies like data integration, data quality, data governance, master data management, and even before that, I used to work in text analytics. So a lot of experience on the unstructured data management and structured data management products over the years. As I'm getting started with the talk around Spark and MarkLogic, just wanted to get the feel from you all in terms of how many of you are using Spark in your organization today, just show of hands. All right, so we have quite a few of you. And maybe others who are not using it may be thinking about it and want to get more information about it. So irrespective of how you answered the first question, also wanted to understand what is the level of familiarity you have with Apache Spark. And this time, on the scale of 0 to 10, if you can tell me 0 means you have no clue what Spark is, 10 means you have written some code against Spark, played with Spark. Anybody? 3, 2, 10, great. 0. All right, 10. All right. Good. So since we have people from all various degree of familiarity with Spark, so I do have a few slides where I will clarify what Spark is and go through some of the core concepts, just to bring everyone to speed, so that when we go into the details of how to make MarkLogic and Spark work together, everybody will be on the same page. So with that, let's look at the agenda. So first, we are going to talk about how Apache Spark and MarkLogic complement each other, how they fit in your overall big data landscape. Then we'll talk about the specific use cases where you may want to use Spark and MarkLogic together in your solution architecture. We will then do the deep dive. We will see exactly how to use MarkLogic with Spark. So we will get into the framework concepts, the APIs, classes, some of the code snippets, and so on. And then we will talk about where we want to take this integration between MarkLogic and Spark going forward. Okay? And then we'll open up for Q&A. So let's look at how Apache Spark and MarkLogic complement each other. So let's just briefly go through what Spark is. So in a nutshell, Spark is an open source cluster computing framework and really built to deliver sophisticated analytics. The origins of Spark go back to 2009 when the project started at Berkeley AMP. And if you remember back in 2009, Hadoop was the new shiny object in the market. And the folks at the Berkeley AMP believed that they could come up with a better cluster computing framework than what Hadoop MapReduce is. And that was the original motivation behind the Spark project. And the Spark is actually faster. For the most part, it is faster than Hadoop MapReduce, mainly because it eliminates some of the inefficiencies in the MapReduce framework by keeping the data in memory as much as possible. Now, if you see the Spark, the benefits of Spark, it really delivers a lot of analytic components. If you see the Spark ecosystem, you have the Spark SQL, you have the machine learning, you have graph analytics, streaming analytics, and so on. Traditionally, if you have seen, all these technologies come as different data processing platforms. They came up with their own engine, their own platform. So the effort from the Spark community here is to bring all these different analytics technologies into a unified framework. Now, since Spark is a framework, it provides the API, it provides the abstractions to easily manipulate the large data sets. The Spark is not a database by itself, so it provides the API from the developer perspective. This API works seamlessly across the SQL or NoSQL database. So your underneath database could be MarkLogic, of course we would like to, and then but it could be HDFS, it could be SQL database and whatnot. Now, if you look into who is using Spark today and what they're using it for, most top use cases around Spark are data warehousing, business intelligence, log data processing, and then there are, of course, machine learning kind of use cases where you use it for recommendation systems, the fraud detection, and so on. The user roles within the organizations typically using Spark are data engineers, data scientists, and the top languages that are being used when using Spark are really Scala, Python, Java, as well as SQL and R. R is the most recent addition that is supported within the Spark framework. So now let's talk about how MarkLogic and Spark fit in your overall big data landscape. Now this is interesting because if you see Spark is, as I mentioned, it's not a database by itself, it's a data processing framework, whereas MarkLogic is a database as well as it provides you a lot of capabilities to process the data natively within the database, close to the data. So with the emergence of big data, as you see, the database, the boundaries between the database technology and data processing framework is kind of fading away. Although if you see the requirements that this technology is addressed, they kind of fall on the wide spectrum. On one end of the spectrum, you have highly operational applications where you have thousands and thousands of users concurrently accessing the data. Most of the times, the queries that these users are making, they need the response in milliseconds because it is something as a part of their day-to-day job. As you may have heard in the keynote speech today, Gary talked about the operational trade store use case or the global trade store use case. So someone in that use case, for example, might be querying a specific swap transaction and all the pre-trade correspondence associated with that transaction. So the queries may be executed on this combination of structured data, unstructured data, but they still tend to be very specific, right? Highly selective queries. On the other hand, if you come to the analytical side, you have your data engineers, data scientists, business analysts. These are the people who are really doing the high-value business analytics. And for example, if you take the use case around log data processing, why do organizations do log data processing? Because there is a lot of information about the user behavior. User behavior patterns you can mine through the log data processing. You can mine the system behavior patterns through the log data processing. But the way those operations work, you're not making a specific query for a specific log event. You're really processing the large volume of log data, applying some analytical algorithm, machine learning algorithm, to get the insight into how your user is behaving, how your system is behaving, and so on. So what happens on the analytical data platform side is you are really doing a massive parallel computation over the large volume of immutable data sets. The reason I say immutable data set because most of the times you are doing analytical either on the historical data, which is not changing quite often, or you are doing something like log data processing, which may have happened very recently, but again, once the log event is generated, nobody is going back and updating that log event, right? So for the large part, you are treating the data as immutable data. And the access patterns that analytical data platforms provide is really the read-only access pattern because of that. On the other hand, if you come to the operational requirements, you have the read-write access patterns. So there are transactions happening, users are updating the data, and as soon as you start thinking about read-write access pattern, you have to think about who has privileges to update the data, what part of the data. So the security, ACID compliance, these are the properties that take very important, that make the very important part of the operational data processing platform, which is what MarkLogic is. Now, having made the distinction between the kind of two sets of requirements, the analytical versus operational, in the real world, when you go and you get a requirements to build an application, most of the times you're going to find that the requirements do not necessarily land on one end of the spectrum. You may end up having to build an application which has operational as well as analytical aspects to it. And in those contexts, you will have to start thinking about using MarkLogic and Spark together as a part of your solution architecture. So let's look at some of the specific scenarios and look into what technologies you will use, when you will use MarkLogic by itself and when you will use MarkLogic and Spark together. Now this first one, I'm not going to spend much time on it, the aggregating data that comes from different sources. As you may have seen in the keynote today morning, David Gorbit kind of walked you through this use case and showed how MarkLogic with its rich document model, the universal index, and things like those, you can easily do this kind of use case with MarkLogic. The second one is again highly concurrent transactions, secured query execution. This is a classic operational end of the use case. You can do it with MarkLogic. Now, third one is interesting. This is the operational BI. So we are talking about a business manager looking at business activities about his or her business area and really want to understand what's going on and trying to stay top on it so they are meeting their objectives by the end of the day, by the end of the week, end of the month, and that kind of scenario. So again, in this case, you are going to address, although this is a BI use case, we are talking about very specific granular queries that you can easily do with MarkLogic. Now comes the scenario where you need to move the data. This is like a batch data movement where you are moving the data, especially the data that you're moving from relational system into MarkLogic. So for example, let's, again going back to the keynote speech today from David, he talked about moving the relational data into MarkLogic, where in relational system, if you are looking at, for example, customer data, it could be spread across 30 tables easily. If you're looking for something like transactional data, like sales order, it could be across 50 to 100 tables. So bringing that data into MarkLogic, you may want to do a lot of transformation on the fly. This is a place where you can use potentially MarkLogic and Spark together to perform this batch data movement. The another one would be, like I mentioned, when you have the hybrid set of requirements, when you are performing analytics over your transactional data, there may be a scenario where you are doing multi-step analytics. And in that case, it's OK to treat MarkLogic datasets as immutable. What I mean by that is when you do the analytics and you perform, if you're populating some dashboard based on these multi-step analytics, it is OK that dashboard reflects the data that it's few minutes old or maybe few hours old. And lastly, you have a scenario where you're performing analytics not only to populate a dashboard, but deriving insights from your data and bringing it back into your operational workflow. All right. So let's dive into the use cases. The first use case I have here is the operational data hub use case, as you may have seen again in the keynotes today, where you have the source system, which could be relational or non-relational. You are doing the batch data movement or data migration, bringing the data into MarkLogic to power up the operational applications that operate on the unified 360 degree of your operational view of your data. So this could be, again, going back to the financial services trade store, this could be your post-trade processing applications that are looking at all the trades that have come from various different systems and that you have aggregated and harmonized within MarkLogic, where MarkLogic is playing a role of an operational data hub. Right? And then as the data becomes historical, you may want to move that data into your enterprise data warehouse to drive some of the strategic BI that is happening. In that scenario, again, you may want to go through the multi-step data transformation where you can implement a Spark data pipeline where you are transforming the data from MarkLogic and making sure it fits within your data model that you have in your data warehouse. This one use case again goes into the advanced analytics. So now we are talking about the analytics that goes beyond the enterprise data warehouse. You may be using things like machine learning. You are taking some of the historical transactions where things have been processed manually, and you are training a machine learning algorithm where you want to automate some of those processes by applying the machine learning instead of putting the human efforts to do some of your workflows. You may be doing things like graph analytics, which you typically don't do using an enterprise data warehouse. You may be doing some ad hoc analytics and so on. And the third use case I have is like kind of a variation of first two use cases, but here we are looking at the streaming data. So as you think about, again, the log events could be a good example. Any data that is generated from machines like sensor data, if you're bringing that data and processing that data, there is a lot of noise that tend to happen in this kind of data. And you can use the Spark streaming component to kind of separate the noise from information and bring the information that you want to act upon into MarkLogic and then power potentially a search or alerting kind of applications based on that. All right, so with that, we are ready to go into the deep dive and start looking into the mechanics of how you would use Spark with MarkLogic. So the first thing is when you use Spark with MarkLogic today, you will be using it via Hadoop connector. The Hadoop connector was originally built, MarkLogic Hadoop connector was built to expose MarkLogic data in Hadoop compatible input and output formats so that you could execute a Hadoop MapReduce job on the MarkLogic data. You can leverage the same technology today to execute the Spark jobs instead of Hadoop MapReduce jobs. The MarkLogic Hadoop connector is certified against Hortonworks and Cloudera distribution of Hadoop. And both of these Hadoop distributions come packaged with Spark framework and Spark libraries. So that is the easiest place to get started using MarkLogic and Spark. So I talked about the Spark job. So let's go through some basic terminology around how the Spark framework works. So in the Spark world, when you are writing a Spark client application, it is called a driver program. And within that driver program, you instantiate something called Spark context. Spark context is responsible for the communication between the driver program and the executor processes that get allocated to it in the Spark cluster. Now, how does that allocation happen? That happens via cluster manager. So the Spark context works with cluster manager, which essentially does the job of resource allocation. It allocates the resources within the cluster to the driver application. The Spark comes with its own standalone resource manager or cluster manager, but it also works with Hadoop Yarn and Apache Mesos as cluster manager components. So when you work with MarkLogic Hadoop connector, you will be using Hadoop Yarn as your cluster manager. The another key concept to be aware of when working with Spark is what is called Spark RDD, or Resilient Distributed Dataset. Think about it more as a collection of objects that are distributed across the machines, distributed and physically partitioned across the machines. Typically, the Spark RDDs are in memory, remain in memory, but you can configure Spark to have these RDDs partially on disk or in memory or fully on disk. The RDD operations can be classified into really two categories. One is transformation and one is called the action. When you apply any transformations to the Spark RDD, essentially what you are doing is you are doing one-to-one mapping of the objects, you are doing one-to-n mapping of objects, or you are doing filtering, grouping, sorting. Any transformation when you apply on the Spark RDD, it effectively creates a new RDD. So as I mentioned to you, the Spark being an analytical data processing framework really treats the data as immutable data. It's kind of built into how these RDD operations are supported. So every time you apply a transformation to the RDD, RDD does not get updated. A new RDD gets created. And the old RDD, if it is not going to be used, then it will get garbage collected. The other part of the operations that you perform on the RDD are really what is called the actions. And the actions are about computing the results, and maybe you want to display those results via the end user application, or you may want to persist those results into the underneath persistent store, whether it's a Hadoop or MarkLogic or whatever persistent store you are using. So this is the code that kind of demonstrates how you load the MarkLogic documents into Spark RDD. So if you see on the top what you are doing here, this is the driver applications. On the top you are constructing a Spark context, you are configuring it. And since you are using the MarkLogic, you will be essentially doing the creating the Hadoop configuration object. And then here, in this case, you are passing the classes and the objects that are exposed through the MarkLogic Hadoop connector. You are calling the API called new API Hadoop RDD to load the key value pair RDD. And this is a Java program, by the way, where the document URI is your key and MarkLogic node, which represents the MarkLogic document as your value. This is kind of a conceptual diagram that kind of shows how the Spark data processing pipeline works. So this is a visual way of looking at a Spark application where you are loading some data into an RDD, you're applying a bunch of transformations, and then you have the actions that are outputting data. So when the Spark looks at this application, it kind of identifies that since there are two actions that are outputting the data, it will launch two jobs. So your job 1 will have the transformations T1, T2, T3, and the action A1. And what Spark has is something called lazy transformation. So until the Spark sees the action A1, it is not going to perform any of the transformations on the RDD. And what that allows it to do is, since it knows now the job 1, what is it made up of, it can do the runtime optimizations when it applies this transformation. So for example, in this particular scenario, the transformation T1 and T2 can be combined together. That's what I mean by the pipeline execution. And when you do these transformations, there are really two types of transformations. One are what is called narrow transformations, where you apply the transformation like map or flat map or filter, and that does not have any impact on how the data that is in the RDD is partitioned. Whereas as soon as you do things like group by key, sort by key, there are a lot of data shuffling that is happening, and the data movements are happening across the network. So something to be aware of when you are applying these transformations on the RDD. And as Spark is executing the application, it keeps track of the lineage, how these RDDs are getting constructed. So in case of failure, if there is a node that goes down, the Spark will go back and recompute the RDD again. So here is an example, which is, I call it MarkLogic WordCount transformation. What it is doing is, I have a set of consumer complaint documents, and these consumer complaint documents have every consumer complaint object has different attributes or different elements, if you think about it from the XML standpoint. So it has things like product, issue, state, zip code, and what this program is, or example is doing is, it is identifying for each element how many distinct values exist in my data set. So on the right hand side, if you see, the product has 11 distinct values, and for each distinct value associated with the product attribute, it is looking at how many times that particular name value pair has occurred in my data set. And if you map this to how the Spark data pipeline would work, this is how it looks visually. First, you are loading the MarkLogic documents into Spark RDD, and then you are mapping those documents into name value pair. And then you have two parallel data flows. One data flow is looking at distinct values associated with each name. And then the another flow is counting the occurrences for each distinct name value pair. And in the end, I'm combining all the two data flows to create a single report, like I showed you in the last page. And this is how this application would look like. So this is a very simple kind of value distribution or discovery kind of application. And there is this application and a blog is already posted on developer@marklogic.com. So feel free to take a look at it if you haven't looked at it yet. And then it also has the pointer to a GitHub repository. So you can go to the GitHub repository, download this application, and look at it in your own environment, try it out. So let's talk about the Spark SQL and MarkLogic. So Spark SQL is essentially provides another abstraction, just similar to RDD, but it is called DataFrame. DataFrame is essentially an abstraction designed to work on top of structured data. So instead of arbitrary objects, you are now working on the structured data because the DataFrame serves the structured query language on top of it. So the way to think about DataFrame is really the RDD plus schema. In addition, DataFrame provides the API which allows you to build the logical query plan. And so there are two ways you can execute SQL. You can pass the SQL to Spark, and it has the SQL parser which will parse the SQL and generate the logical query plan. Or you can build a DataFrame API itself to build that logical query plan. No matter how you build your query logic, it will go through the same SQL engine and the optimizations. Now, the data frame has specialized API to load data sources, and but in case of MarkLogic, the way you would load the data in the data frame is using the existing RDD. So we already looked at how to load the documents into Spark RDD. In addition, if you want to load that data into a data frame, what you will do is you will create the SQL context object, and then you will use the API apply schema on the SQL context. And the way you would do it is you would take this MarkLogic document, put it in a class. So in this particular case, I have the consumer complaint class, which is a Java class. And when I do the apply schema, I'm simply passing the class definition, which serves as the schema for my objects. And that's how I get the data frame. And once the data frame is created, I can register it as temporary table, and I can execute the SQL on it. Now, one thing to keep in mind is that MarkLogic has its own SQL capability. So when would you use the MarkLogic SQL versus Spark SQL? The answer is really going back to the earlier scenarios when we looked at the operational BI scenario where your queries are going to be granular, very specific, selective queries, you would use the MarkLogic directly. When you have to do multi-step analytics, data warehousing kind of scenario, then you will be using Spark SQL. All right, and then we come to Spark machine learning. So in this scenario, we are going to use we're going to look at how you can use the Spark machine learning working with MarkLogic. How many people here have used machine learning? All right, cool. So as you know, the machine learning applications tend to have really two different data processing pipelines, if you will. So the first one is the training data, where you take the training data, extract the features from the training data, and then usually the training data has manually assigned labels, how you want to do, and then you use that to train a model. So in the case of Spark, there are two specific abstractions again to look at. One is called transformer. You use the transformer to really extract the features. The input to a transformer is a data frame and output is a data frame. And when you apply the feature transformer, what you're getting is your input training data gets appended, if you will. The new data frame that you get has additional columns, if you will, that has the features that you extract assembled. And then the another interface is estimator, which is really used to train the data, to do the training based on the training data and generate a model. So the model is typically which encapsulates your machine learning algorithms. So you may have machine learning algorithms like classifier or collaborative filtering or clustering. All those algorithms are encapsulated in the different estimator classes that come with Spark machine learning library. And typically your training data pipeline looks like you have a data frame where the input data is coming in, you're extracting features, you're training data, and then ultimately what you have is the model that you can then use in your testing or production scenario. In the testing or production scenario, you again have the new data that is coming in, and you're applying the machine learning model to predict something about that data. All right. So here is an example which is really about credit risk assessment using machine learning. So what you have here is a loan application or credit application which has various different attributes, again, things like account balance, credit history, credit purpose, length of residency, length of current employment, and so on. And these attributes are the ones that essentially participate in a machine learning process. So typically what happens is somebody manually reviews all this information and associates a credit risk with this particular credit application. Now you want to replace that manual process using a machine learning algorithm. So the way you would do it is you would load the credit rating training data from MarkLogic into a Spark data frame. And then here, in this case, I'm using a vector assembler transformer, which is assembling the features, extracting the features and assembling the features, so that we can use those features as a part of the machine learning process. The assumption here is that you are taking the historical loan applications which have been manually processed and credit risk has been manually assigned, because you are doing the training. And so as a part of that, step 3, you are organizing these manually assigned labels in a way so that you can pass it to your estimator class. The estimator class being used here is called the random forest classifier, which is typically the class, as I understand, is being used in fraud detection, risk assessment kind of scenarios. And once you have the machine learning model that is trained, you can use that model at runtime as the new loan application comes in. You can go have this particular data pipeline where you are using again the vector assembler to extract the features, and then you are applying the model that you have previously learned from. The model in this case acts as a transformer itself. So your input again is data frame, and the output that model generates has the labels associated with it. So in this case, the credit risk label will indicate whether this application has the risk associated with this application. So for example, is it a good credit, and should the application be approved right away, or should this be put into the further review process, because at least the machine learning indicates that there may be significant risk associated with this application. Yep.
So with this credit risk example, if you then find out that the calculated risk is too high or too low, what's the process for retraining the algorithm?
Oh, you want to retrain it?
Yeah, if you don't think it's right.
Yeah, so there is going back to what will happen is there is a lot of tuning that goes on typically, how you would do that. So if you look at this code, first of all, how you have sampled your data. So typically training data is not all the historical data you take the sample data. But since you are using this in the cluster, you can take large volumes of training data as well. And then there are a lot of things. So for example, here, these are the configuration parameters. I'm not necessarily the expert or data scientist who understands all these things, but this is what your data scientist and data engineers spend a lot of time into, understanding, have they captured the right features that are participating in your machine learning algorithm? Are there any features that they're missing? Are these configurations correct? So there is a lot of tuning that goes on typically in this process to get the desired accuracy. All right? So what's next with MarkLogic and Spark integration? So at least the idea from that we believe is what we could do about this is what we call the native Spark connector for MarkLogic. The idea with the native connector is that it will have no runtime dependency on Hadoop Yarn. Essentially, you can still use Hadoop and Yarn if that's how you want to use your Spark and Hadoop together. But you don't have to. You can use Spark standalone cluster manager as well while working with MarkLogic. And it will simplify the API for working with Spark RDD. So for example, we looked at the API initially where we did like new API Hadoop RDD, and we passed a bunch of Hadoop classes in there. In this scenario, we expect the code will be simplified and will look something like this, where you're using the API directly on Spark context, where you're generating the new MarkLogic RDD, passing the MarkLogic specific parameters, and a filter query where you can use the filtering, push down the filtering within the MarkLogic. So you're extracting the data, only the data that you need in Spark. And you should be able to save any arbitrary RDD into MarkLogic in the same way. And with the Spark SQL, again, Spark SQL has a API called Data Source API. So the native Spark connector can take advantage of the Data Source API and populate the data frame So again, API to populate the data frame becomes simple, and also it has the ability to push down filters and such things within MarkLogic. So again, to API to create a data frame becomes simpler, and also there will be an ability to save an arbitrary data frame to MarkLogic database.
So does it like flatten the tree structure of the XML? Say you have XML hierarchical element nested inside the element.
Right.
How does it work with, in the data frame?
Data frame, you will end up flattening it. So in that context, if you look at how, again, Spark being an analytical data platform, it treats the data as tuples, basically rows and columns, or you end up treating it as key value pairs. So you kind of lose that richness in terms of doing the queries or the operations that you have in MarkLogic.
So say I have element, parent element and child element. And, so you're like a parent or child in the data frame?
Oh, the data frame will not be able to express that kind of data structure. Because in the data frame, as I mentioned to you, it is mainly designed for structured data, so it will be always flat. But you can transform, potentially in that case, you will be transforming data frame to an RDD. RDD can take any arbitrary object. So like first time, if you see in the code snippet I created the RDD, it was the MarkLogic node object, which can be hierarchical, for example, right? So in that case, that transformation from the structured or the tabular to hierarchical will have to happen. You'll have to take the data frame row and convert it into a proper hierarchical model to express that.
So is your application needs to do this kind of transformation?
Yes, that is something that the logic you can build in Spark as well. Or you can bring the logic as a flat document into MarkLogic, and then you can enrich it within MarkLogic once you have it in MarkLogic, using this xquery or the server-side JavaScript in MarkLogic.
Yeah, because in the Spark, there is like a JSON. JSON, you can save data as a JSON format.
Right.
Or read from the JSON format.
Correct.
Which is like hierarchical.
Correct.
You could automatically flatten.
That's right. So in that case, it gets flattened. So that's why I said that if you need the richness of the hierarchical model, then there will be some code involved. And that code can be either written on the Spark side or MarkLogic side, depending on how you want to implement it. All right, so with that, we are pretty much close to the final slide. So the key takeaways, what we looked at in this presentation is Spark is an open source big data cluster computing framework. For the most part, it is faster than Hadoop MapReduce, really built for sophisticated analytics. MarkLogic, when you compare MarkLogic and Spark, when you use it, MarkLogic is your operational transactional database, really designed to support highly concurrent transaction and secured query execution, whereas Spark is really about massive parallel computation over large immutable data sets. MarkLogic and Spark work really as a complementary technology, addressing the hybrid requirements when you have to address operational plus analytical requirements in your application. You will be using Hadoop connector, writing a Spark application against MarkLogic, if you have to do it today. And then typically you will end up loading the MarkLogic data into Spark RDD or Spark DataFrame before you can start using it within Spark application. And what's next, we looked at native Spark connector for MarkLogic.
When do you anticipate your native connector to come out? Just curious.
When do we anticipate? Right now, there is no specific timeline associated with it, but we are continuously looking for the feedback from customers and what you are looking for, and based on that, it will be prioritized. Again, if you want more information, you can go to the blog on developer@marklogic.com. You can go to the GitHub repository, download the example application that I showed you, and feel free to use it in your own environment. All right. And then we are open for question and answers.